All right, let's dive right in. Today, we're opening up the programmer's toolbox to get our hands on the absolute essentials of Python. We're talking about the core data structures that organize and manage all the information in your code. Let's get to it.
You can think of it this way. Every single program you write, from a simple game to some complex AI, it needs a way to store and handle data. Well, lists, tuples, sets, and dictionaries, these are your fundamental tools for that exact job. They're basically the hammers, screwdrivers, and wrenches of your coding world.
So here's our game plan. We'll start by filling up our toolbox, taking a look at each of these 4 essential data structures, one by one. We're going to see what they are, how they work, and, most importantly, when you should use them. Then we'll wrap it all up with a quick guide to help you choose the best tool for any task.
Okay, let's get our hands dirty. And remember, these aren't just some abstract concepts. They are the practical, everyday building blocks you'll be using to build efficient and really powerful applications.
First up is the list. And seriously, if you could only have one tool, this might be it. It's just incredibly versatile, it's flexible, and you will find yourself reaching for it all the time. It really is the Swiss Army knife in your Python toolbox.
The 2 key words to remember here are ordered and mutable. Ordered just means that the items stay in the exact sequence you put them in. And mutable? Well, that's just a fancy way of saying you can change the list after you've made it. You can add stuff, remove stuff, or swap items around.
And creating a list is super straightforward. You just use square brackets and separate your items with commas. So here, we've just made a list called fruits with 3 strings in it. It's as simple as that.
And here's that mutable idea in action. We can target an item by its position, its index, just remembering that Python starts counting from 0, and then we assign a new value. So here, fruits at index 1, which was banana, becomes blueberry. The original list itself has been changed.
So what if you need to add something new to your list? No problem at all. The .append method just tacks a new item onto the very end. See? Our list of fruits just keeps on growing. It's super flexible and dynamic.
All right, let's move on to our next tool. If a list is like a shopping list written in pencil, a tuple is one that's been carved into stone. It's for data that you really want to protect and make sure never, ever changes.
The key difference here is that one word, immutable. Now, like a list, a tuple is ordered, but it cannot be changed. Once you create a tuple, its contents are totally locked in. This is fantastic for protecting data that you don't want to accidentally change, and it also makes them a bit faster and more memory efficient than lists.
You create tuples using parentheses like this coordinates tuple. Now, watch what happens when we try to change that first element. Python immediately throws an error, and this isn't a bug, it's a feature. It's there to guarantee your data stays constant and secure.
So, to sum it up, lists are for collections that need to change and grow over time, maybe like a list of users signing up for your app. Tuples, on the other hand, are for data that should stay constant and protected, like the days of the week or a set of geographic coordinates.
Okay, next tool in the box, the set. The best way to think about a set is like a filter, or maybe a sieve. Its main job, really, is to enforce uniqueness. If you pour a bunch of items into a set, only one of each will make it through.
So a set has 2 defining features. First, every single item inside it has to be unique. And second, sets are unordered, which means the items don't have a specific position or index like they do in a list or a tuple.
Now look at this. It's almost like magic. We create a set using curly braces, and we give it a bunch of numbers, including a few duplicates. The moment that set is created, poof, all the duplicates are just gone, leaving us with one of each. It is incredibly efficient for cleaning up data.
But beyond just uniqueness, sets are fantastic for doing these kinds of mathematical operations. A union, using that pipe symbol, combines all the unique items from 2 sets into one big set. An intersection, with the ampersand, gives you only the items that appear in both sets, which is perfect for finding the common ground between 2 different groups of data.
And now for our final major tool, the dictionary. If a list is just a simple container, a dictionary is more like a sophisticated filing cabinet. It's not about the order of things, it's all about being able to look up information instantly using a specific label. The core idea here is the key-value pair. Every piece of data, or value, gets stored with a unique identifier, or key. It's just like in a real dictionary, where you use the word, the key, to look up its definition, the value. So dictionaries let you use these keys to label your data. just like putting labels on folders in a filing cabinet. This means instead of looking for an item by its numerical position, you can pull it out directly using its unique name. This makes finding specific information so incredibly fast and intuitive.
And just like a real filing cabinet, it is so easy to add new information. You just create a new labeled folder, a new key, and you put your data inside. The dictionary just instantly expands to hold this new item whenever you need it to.
Okay, so we've filled our toolbox with 4 really powerful tools. Now for the most important part, knowing which tool to grab for which job. Let's put it all together in one clear view.
This table right here, this is your ultimate cheat sheet. So if you need a flexible, ordered collection that you can modify, use a list. Need to protect ordered data from being changed? Grab a tuple. Need to find unique items or see what 2 groups have in common? A set is definitely your answer. And if you need to store labeled information for super fast lookups, a dictionary is the perfect tool for the job.
And there you have it, a solid foundation for how Python organizes information. Your toolbox is now open, the tools are in your hands, so the only question left is, what are you going to build first?